Hi, everyone. So I'm Connell. I'm the CTO at Zappar. I thought I would tell you a little bit about WebAR, but I'll just give a very quick introduction to Zappar first. We are a creative consultancy and a technology platform rolled into one. We've been working for 8 years now, and what this means is that we help our customers and our clients build content, but we also make our tools available for everyone so that they can make content of their own. That's all about our mission, which is to democratize AR, VR, and MR, and to provide solutions that are mass market scalable. So that means the technology is scalable both in terms of traffic, so like how many users are accessing your content, but also in terms of device support and ease of user experience. So we want it to be possible for anyone to create this kind of content, and then we want it to be possible for anyone to experience and consume that content, regardless of what device they have or how technologically savvy they are. And a core part of that is our platform, the Zappar platform. What it is some hosting and backend services. We have a complete content management system called ZapWorks that allows you to build and manage AR, VR, and MR content. We have a set of content development tools for building it, and we'll see one of those tools in my talk. We have a really lightweight 3D rendering runtime. So that's the bit that runs on your phone or indeed in the browser, as we'll see, and takes the content that you've built with those tools and shows it to the user.
You can get the QA whenever you want.
Oh, great. Fab, great. Thank you, cool. And we'll have plenty of time here, guys, so if you have any questions, any questions at any point, just let me know, put your hand up, and we can take them as we go, because there's lots of bits and pieces where we might have different questions. Cool. So we have a ton of computer vision algorithms as well, which are, of course, built and completely integrated into our platform. And then we have analytics. We call it Zappalytics because we like joining words together. That allows you to understand how well your content is performing. And we wrap this all up into a single unified platform for building and deploying AR, VR, and MR content. So the agenda. WebAR, a little bit about the what, why, how, and when. The only word we're missing is where, and that's because with WebAR, it's pretty much anywhere. We'll have a demo, Wi-Fi permitting. Then we'll talk a little bit about distribution mechanisms, how you serve this content to users, different triggering mechanisms, which are how you identify the content that you want users to see. We'll have another demo and make some more content, and then we'll have any other business at the end. Cool, all right. So let's start with the what. So what is WebAR? It allows you to provide augmented reality experiences to users right in their web browser. So users can have that experience by visiting a website. There's no need to download or install an app. So you can see in this screenshot, this experience is running in Safari. Now, so Wi-Fi permitting, let's have a little demo of some WebAR. Let's see here. So I've got a little extra light. I'm going to try and pop out here into QuickTime so that we can have a look at the screen of my phone here. Select the phone. With any success, we see the phone. No success so far. Let's try again. Oh, and we drop my phone repeatedly. Any QuickTime, any screen recording. I'll try plugging it in and out again. Ugh. Movie, yes, sorry, my mistake. Oh, I've done this like a million times. Here we go, okay. Yes, thank you. Bonus points for you. So here is web.zappar.com. So basically a mobile version of our app running in the browser. I can hit the launch button here. So yeah, this is just normal Safari on this phone. It shows me the camera. I have my business card here with content that was published like a while back. I scan it, and there's the content running in the web browser. I can hit rescan, and I'll scan the back, code there. And this side of the business card demonstrates some 3D content. So a little tennis game, if I can press the button. Oops. Oh, but I just failed straight away. No worries. So it demonstrates some more of the features. Cool, so that's really quick demo of WebAR running in the browser. Thank you. Presenter view. And then I had a video of exactly the same thing, just in case the Wi-Fi didn't work. So we can skip past that. There are lots of reasons why WebAR is great. I'll give you just 3 here right now. So the first is that since no app is required, users don't have to search the App Store or wait for any download or installation of an app. So it means that they get into experiences faster and within a minimum of fuss. It reduces the barriers to entry at each step for the user. And when you're publishing content, you don't need to pay any existing apps or social networks to access their install base. To put it simply, every smartphone has a browser, and that's your audience. Since the interaction takes place completely in the browser, novel use cases are unlocked that are just not possible or feasible in apps. So closer integration with existing online ecosystems is possible, as is novel monetization strategies that avoid that 30% App Store fee or are otherwise unsuitable for distribution in the App Store. And since no app submission or review process is required, it's possible to fully publish branded AR microsites with a super fast turnaround and to iterate on those user experiences with a much more predictable time frame. So those are just 3 of a much wider set of advantages. It is a challenging thing to do, WebAR, and it's exciting, but in order to hit that mass market requirement we have from our mission statement, we have to think about these challenges. And the first is that web browsers can't perform the complex computer vision calculations necessary for WebAR nearly as quickly as native apps can. This is getting better as both devices and browsers improve, but as it stands, browsers are typically about half as fast, and for some calculations, an order of magnitude slower at performing them. While the standards that govern the web are changing relatively slowly, the browsers themselves are changing quickly. Sometimes this is to introduce new functionality or new user experiences, and sometimes it's to address security or privacy concerns. You may remember the high-profile vulnerability disclosed last year called Spectre. Well, to mitigate against that, browsers removed a key component of the browser, which is needed to perform calculations quickly. And so that's challenging. We have to accommodate that. And those changes happen with a development and release cycle, which you don't control. It's the browsers that control that. Even just last month, Apple disabled by default the access to sensor data in Safari to address privacy concerns. People were using the accelerometer in your device to profile your device so that they could know your device from other people's devices in what's known, I suppose, as a fingerprinting attack. And so to avoid that, they disabled access to that. You have to go into the settings of your phone to enable a feature to get access to that. And that means modifying the user experience of WebAR systems like ours, where you have a legitimate use for that data. There are some features that we're used to in apps that require functionality, just not available in browsers yet. Even something as simple as sharing a photo over email is tricky within the browser. There are web sharing APIs, which are quite in their infancy and can handle text, but not images yet. So the alternative to that is to share using an intermediary third party, which involves lots of personal data. I keep dropping that. I'll put that there. Personal data concerns. Where were we? Oh yeah, so another missing component in the web APIs is lack of camera control. So in Safari in particular, in low light conditions, instead of keeping the frame rate high, Safari will reduce the frame rate and increase exposure for the frames that it gives you. Now, normally for computer vision real-time applications, you want to keep the high frame rate and just deal with a lower signal-to-noise ratio. So your noise, the frames you get from the camera will be noisier, but we're happy dealing with that if we can give the user a smooth experience. Safari and indeed the Chrome, you can't get the access to control that setting like you can in a native app. And the final thing to say is that the necessary browser technologies that we're using here are pretty young, pretty new, and so maybe unstable or buggy while browser developers iron out the kinks. So there are elements of that which are WebAssembly, which is a really important technology, but relatively new in the browser. We indeed had a bug fix in Chrome that we reported to the Chrome team last year that was necessary to make this possible. So we really are kind of at the bleeding edge of browser technology here. So Zappar's solution to the WebAR problem. So we've been working hard to make sure that our platform realizes the opportunities of WebAR while addressing these challenges. So going forward at Zappar, WebAR is a first-class platform for our ZapWorks content management system. So what this means is that functionality we build for our native iOS and Android apps will be made available in WebAR straight away. All ZapWorks content, both existing and new, will run in the browser. So there's no need to explicitly modify your content for WebAR. Experiences built using our tools like Studio, which we'll see in a bit, and the other tools like Designer and Widgets will just work. There are a small set of caveats where certain features that are not supported by the browsers won't work, but we've put in place graceful fallbacks so that the user experience is protected in those circumstances. Zappar's WebAR is working in the regular browsers already running on users' devices. So they don't need to download or install any special or pre-release browsers to use WebAR. The version of Safari or Chrome that came on their device will work. WebAR really stretches what web browsers are capable of, and so we'll consider WebAR to be a beta technology while browser support improves. This comes back to our mission statement about mass market. When you're shipping content that gets hundreds of millions of engagements, as we do, it's super important that the stakeholders in that content understand the technology, its constraints, and its corresponding opportunities. And so, of course, as we go, we'll continue to optimize our implementation to get the best out of these existing devices. Just to give you kind of an idea of some of the features that work in our WebAR straight away. Image tracking, face tracking, 360 panorama images and video that you can look around, animated 3D models including rigged characters, physically based lighting, transparent video, that's like video with an alpha channel, so somebody that's been in front of a green screen or something like that, you can use that type of video. Full analytics, and with us you get first-party data for analytics. So with our custom WebAR sites, we can use your Google Analytics tag, for example, so you can see and analyze the data yourselves. Scripted experiences, ranging from really simple things to complete gameplay. And then, of course, full adaptive quality, aka Netflix-style streaming video that works out how good your connection is. So those all work straight away in Zappar's WebAR. Sometimes, however, it's best to go native and stick with a native app that you install. And the cases where, or here's some reasons, I suppose, why you might want to do that. So if you have super high fidelity assets, like high polygon 3D models or high resolution textures, memory management in the browsers is much harder, and Safari and Chrome have a habit of just giving up on your page if there's some memory pressure, and you get an snap on Chrome, or just a little meaningless banner that's difficult to get rid of on Safari. So it's, if you've got really high quality stuff, you might want to consider using a native app. If you already have an existing app ecosystem that you want to leverage or promote, if you're using one of the relatively few features that aren't available in browsers, of course. If you want to preload content in like a download-upload step, this turns out users are more tolerant to an app installation taking longer than, say, a loading step once you get into the app. I think they kind of think of the app installation as a sunk cost, and then when you're in the app, their attention is fresh and they want to be able to get in straight away. So if you want to preload content, that's maybe a good reason to go through an App Store installation. And if your target audience are in regions with high numbers of low-end devices where the native performance bonus is really helpful. Cool. All right, well, I thought at this stage we could build some content to see how that process works. Unless there are any questions so far, I'll just keep going. Cool, nice. So I'm going to show you building some content in Studio. This is our most powerful tool in the ZapWorks feature set. It allows you to build fully 3D interactive experiences. We have simpler tools, which are more, I suppose, drag and drop, and just have a kind of simpler, cleaner user interface. But it's very much our intention with Studio that it's as easy to use as possible. So even if you're not a scripter, you can get in and use Studio. If you're not a 3D modeler, you can use Studio. So it should be pretty approachable for most people. So I thought that we could build a face tracked experience and have a look at it in WebAR. So I have here, there's a template in Studio for building a face tracked experience with this racing helmet. I'm going to create it. I'm just going to put some random at the end because I've already got a project with that name. And we'll go in here. And this takes us into the Studio editor itself. I'll just take you around this interface a little bit. On the right here, you have your media library. This is where all of the raw assets you need for your project will be. On the left here, we have what we call the hierarchy. So that's a list of the things that are in your experience. So in this one, you can see we have Zappar helmet, which is the 3D model that's shown in the center. We have a face group, which is the 3D tracker in our technology for the face. And you can see here, there's different sections under it for the origin, or the left eye, or the right eye, or mouse center. We actually have a ton of those where you can place content. And that content, even if the user moves their face, will, or like deforms their face, will put it in the right place. And we have various other bits and pieces in there. We have properties where you can edit what your the properties of the objects in your hierarchy. We have a pretty novel animation system, which we call controllers, states, and timelines. And it allows you to build user interfaces that are stateful with different sections and areas, and to build timelined animation between them. And of course, in the 3D view in the center, we have a preview of what we're building. So in this case, it's the model, and you can zoom around and have a look. So it should be the case that we can just go ahead straight away and preview this. So let's hit preview. What happens is Studio uploads this content to ZapWorks, our CMS system. It verifies it to make sure that it all makes sense, and compresses all of the assets and makes it all ready for viewing on a mobile device. And at the end, it gives us a code that we can scan in either the Zappar app or, as is the purpose of this talk, the WebAR version of Zappar. So let's see if we can bring back QuickTime with a movie recording. And there we go. So I will just, I'll move that way, press launch here, allow access to the camera. I'm going to scan the code. At this stage, it downloads the content, and then with any luck, we'll see me with a helmet. Now notice the frame rate is quite slow here. That's because of that issue that we discussed about the exposure control. And like my face looks really, really pale. I mean, my face is really pale anyway, coming from Scotland. But like the exposure here is not what it should be. But we can thank Safari for that. Cool. So yeah, under normal lighting conditions, that's like full frame rate. So you can look around, and it's a good experience. So I thought I would demonstrate just one other thing in this demo. So I will, so we've got our helmet here. We also now have Sketchfab integration in Studio. So if I want to try a different model there, we can go in here and we can search Sketchfab's entire library. So I happen to know that there's a top hat. So we search. It's kind of low poly and it's pretty suitable. So I'm going to import that. It downloads that model from Sketchfab on your behalf. We can have a little preview of it here, but let's just say finish. We will get rid of the helmet from our hierarchy. We will introduce our top hat in here, which is not in the right place, but we can reposition it. Let's move that up here, and let's make it bigger. It's not going to win any awards, but it's good for the moment, so let's hit preview. We'll bring QuickTime back. It's back in scanning mode for Zappar, so we'll be able to scan the code it produces. Just get infinite camera effect. there we go. So I'll scan that code, downloads the updated content, and there we are. Rather fetching top hat. Cool. Thank you. Close that bit down, and let's head back to the presentation. So we've got some more slides. Cool. So when you're building AR content, one of the most important considerations is the distribution mechanism. So how are users going to access your content? And typically with Zappar, you have two choices. So you can deliver your content for free through the Zappar app, or you can embed your content in your own app. WebAR now offers two additional ways. So there's web.zappar.com, which is very much like the Zappar app, but just running in your browser, what we've seen. And there's the option for a branded microsite that can be integrated into your existing online user experience. And so if you're a brand that's working with your own ecosystem, we recommend that when you invest in innovative content like AR, VR, and MR, do so to strengthen your own ecosystem rather than that of a social network or another app. That's why it's really valuable for brands to have that white label option. And for people that don't have an ecosystem, they can always use the Zappar ecosystem for free. Once you have worked out how you're going to distribute your content to users, you also need to know which piece of content a given user wants to access. So that's because with the Zappar platform, you can publish unlimited numbers of experiences that all are viewed through your app or microsite. And so we use the concept of triggers to talk about how users launch a given piece of content, and we have a number of supported trigger mechanisms. So the first, and perhaps the most simple, is the deep link. It's just a web address that launches straight into a given AR experience. So no app is required for the link to work. Users can tap on the link online or from a message, and it will launch the content straight away. The links can launch either a native app if the user has it installed, or it can fall back to WebAR if they don't. And now one con here is that if the user has encountered a link on a piece of kind of real-world printed media, then they may have to type it in, which can be uncomfortable and error-prone user experience. Now, every project in ZapWorks already has a deep link, but soon we'll be launching functionality that lets you generate links that can fall back to WebAR experiences if there's no native app installed, and we'll add support for custom domain names and branded WebAR microsites. So the next we all know is the humble QR code. So it's a unique code per piece of content that users can scan to launch the experience. Many users are already aware of QR codes and how to scan them, which is great. Indeed, many operating system provided camera apps can scan QR codes, iOS being a salient example. Unfortunately, support is far from ubiquitous. Here's a screenshot from Google's camera app, which is shipped on many Android phones. And you have to tap this rather obscure icon in the corner to launch Google Lens in order to scan a QR code. And then to add insult to injury, if you launch the camera without unlocking your phone, the button is mysteriously absent. So while QR is great in some ways, there are challenges when it comes to user experience for instructing and educating users of how to access your content, especially when you're trying to reach that mass market scale where users haven't necessarily installed or interacted with the QR code before. Some people also have QR fatigue, which is when they've been burnt out by having a QR experience in the past that hasn't been very good. So people kind of associate it maybe with going to a mobile optimized website, or sometimes a non-mobile optimized website. So there's that. But that said, it's a great way of getting users into an experience. And in the near future, the Zappar app, both the native apps and the web version, will support scanning QR codes, and ZapWorks will gain functionality for generating them. So I thought here I could show the user flow a little bit of getting a QR code experience. So let me just escape out of that for a sec. Hopefully we'll have that QR code still on screen. And let's bring QuickTime back. Movie recording. Oh, and it's me. There we go. So I'm just going to go into the camera app on this device, normal camera app. going to point it at the QR code, which it recognizes in the top. I tap it to launch. It takes me to the usual page. I have to hit the launch button. So it's really important, actually, that we have that launch button, because in order to access the camera feed, we have to do so as a result of a user gesture. So Safari will only let us get the camera if the user touches your page. And so that's why we have the launch button. And then it launches straight into that same experience that we had before. So pretty seamless user experience for getting straight from a camera to a WebAR experience with absolutely no app involved at all. Cool. OK, let's pop back to the presenter view. We had a video of that experience in case the Wi-Fi didn't work. Another trigger mechanism we have at Zappar are custom barcode schemes. So since it's basically a totally unique branded code per piece of content, and since the content that these deliver is always rich and immersive, so very rarely do one of these codes ever go to a poorly optimized mobile web page, users learn to associate these codes with the brand and with a positive experience, so they're more likely to scan the future codes that they see. They also scan really quickly. So we only need a single camera frame, and the code can be really small in shot for us to scan it. So it's our intention that users don't need to make an explicit gesture to point at the code in order to scan it. If it's on a printed page in the corner, just looking at the page should detect it and launch that experience. But of course, since they are not supported by the OS camera apps on devices, users have to install an app or visit a microsite in the AR world, in the WebAR world to start scanning. But if users have already engaged in your ecosystem, so they already have the app, say, this may not be a problem. And as we discussed when talking about QR codes, the OS camera apps for scanning are a bit of a false idol because of the lack of ubiquity of the scanning experience. And finally, we have cloud image lookup. This is where the phone uploads images to a server for identification from a large database and returns the ID of the content to show. It's great because you don't need to alter existing printed materials to add a code or anything like that. So it's great for things like magazines with lots of pages or large collections like book or DVD covers. There are a number of considerations, however. A good low latency network connection is needed to make this feel really smooth, much more so than code scanning, which we can do entirely client-side on the device. The server infrastructure for supporting this is more resource intensive, since it has to run computer vision on the images that the phone sends. And again, the user must launch an app or a microsite to start scanning. At Zappar, we have a super scalable implementation of this technology, so you should just drop us an email if you're interested in using it. We don't recommend it for lots of the reasons we've listed here in some cases, but there are really good use cases for this technology, which we've deployed in the past, so it's there if we need it. Cool. All right, I thought we could build a little bit of more content as a little rest from the slides. So I'm going to head back to Studio, and we'll close this one. And I thought I would start with a really fresh bit of content and a really fresh project and add some different content for my business card. So I'm going to start with a blank project here. I'm going to click Create. I think that's the first time I've ever typed something in a presentation correctly the first time. OK. So here we have a completely blank project in Studio. So I'm going to bring my business card to life. I have a JPEG of my business card on my laptop, business card. So I can select that. I'm going to tell Studio whether I expect it to be flat or upright. That doesn't actually matter from a computer vision perspective. What it's doing is letting Studio know the way that's going to be best for me to navigate around that when I'm placing content. So I'm going to make it flat. I go next. And then Studio goes away and just for a couple of moments looks at this image from lots of different angles to work out what it looks like. And that ends up producing a little file which, when we publish this experience, will get sent to the phone so that it knows how to look for this image in the camera. And that lands up as a target in our media library. So in order to build content on it, I just drag that target into my projects, into my hierarchy on the left, and we can see it here, and I can look around it in order to put some content. I also have prepared a rather 1990s looking button, which I'm going to drag into my project as well. And I literally just drop that onto my target. And then let's do a little bit of scaling. Get it here. Cool. Now I want to make it so that when you tap on this button, it launches Twitter, our Zappar Twitter page. And there's two ways we can do that. The first is really simple. With the image selected here, under Actions, I can just go Add, on tap, Launch Web Link. And then here I put the URL. That's Zappar app. And then when we preview this, it should work. Let's give it a go. And bring QuickTime back, which it's still got. Back into the browser. Let's just go to normal web.zappar.com. QuickTime. I'm going to launch that. Allow. Let's get the light up there so it's a wee bit easier for us to see. I'm going to scan that code, point at my business card, and there's the button. And when I tap on it, it lets us pop through to the Twitter site. Cool. I'll pop back. Thank you. Now, of course, with Studio, you have these actions, but for users that are a little bit more involved, you can also script. All good?
Yeah, but I think they were so amazed that they were too shy to ask questions or shocked. So I can't believe you don't have a question there. So, any question on what you just saw? No, everything I'm the only. Yes, just a sec.
Hi.
Hi.
So what is the like sort of the rendering engine running on? Is it like 3GS, or is it because it's a web-based experience?
Yeah, it's our own rendering engine.
So, okay.
It's actually natively implemented, so it's the rendering engine we've had and used at Zappar for a long time, and we have compiled it for the web using WebAssembly. When we started with Zappar, the Unity had just started. We considered actually using Unity as our rendering engine. It turns out it's quite hard to deliver Unity over the air. And also Unity has quite a big runtime. So we built our engine at the start just to be super lightweight. So all of those features that you saw in that little matrix list, they're all available straight away in our web runtime or our native app. And on the web, our web runtime compiles down to 1.5 megabytes of WebAssembly. So it's really fast. And indeed, we try very hard to make sure that that actual download happens when the user is thinking about pressing the launch button. So when you first visit the page, it's like 30 kilobytes. Whilst your finger is moving towards the launch button, it's downloading that 1.5 megs. And then normally, within a second or two, you're into a camera scanning view that can do all of those features. So we kind of lucked out in that regard by having a lightweight platform from the start, which means that with WebAR, we're set. We're lucky. Cool.
Question. Obviously, I'm doing questions. Sorry, we're doing questions. I don't know why I had to say question. Anyway, hey, I missed the first couple minutes of the conference or your talk, and I wasn't sure. Is this only just for mobile devices, or are you guys talking about using it with HoloLens or Oculus or anything for that matter?
Yeah. So I suppose there's two answers to that question. One's the kind of just normal Zappar answer from our business, and then there's a WebAR specific answer to that question. The first, when it's talking about Zappar, we support a number of headsets, like Google Cardboard style headsets. We have nothing to announce at the moment on other hardware, but it's definitely something we look very closely at. We try to make informed decisions about which platforms we support, and because as an open platform, a platform where the tools are open for anybody to use, we have to make sure we don't make promises about platforms that we then don't want to support in the future. But we very much are open to looking at them. In the WebAR sense, the answer is a little bit different, just because for these devices, getting 30 FPS on a camera is not enough. You really do need 60 FPS for mixed and virtual reality experiences involving the camera. And just in the browsers, you can't get that at the moment. I'm sure that will change as we get more control over the camera. So we have a mixed reality headset project ourselves called ZapWorks, which is basically like Google Cardboard for mixed reality, where you've got headset and cardboard controllers, and for like $30 you can have a mixed reality experience rather than paying a lot more for a headset type experience. It kind of is down our democratization and mass market mission, which is at the kind of heart of what we do at Zappar. And so our support of that will depend on getting access to more camera stuff in browsers. So we're motivated, I suppose, I should say, in making it work. Cool. Hi.
Hey there, thanks a lot for the talk. I was wondering how much interaction can you actually put into with the Zappar Studio? So in terms of, you mentioned state machines and transitions with animations. So basically, could you create kind of a small game with it?
Absolutely, and indeed, our platform is deployed in that way all over the place. So just to give you an example, so here in our Twitter button, we have used an action to imbue that interaction, but we can right-click on our button and create a new script, pointer down, and we're into like a scripting environment. So this is all TypeScript, which is, I suppose, a fancy version of JavaScript. Everything is kind of autocomplete, so if I wanted to do the same thing, I'd just do this. And it was Twitter we were going to. The editor we embed in Studio here is Monaco, which is the same one that's used by Visual Studio Code. So it's quite a kind of familiar development environment for people. And our creative team at Zappar, but also externals, have used this to make really quite complex gameplay experiences. What turns out to be the constraining factor is the occasion and context of users when they're engaging with this type of content. So the Zappar platform is really good for fast content that users consume for short amounts of time, but repeatedly and regularly. So for example, we do a big campaign with 7-Eleven. They have a rewards app called 7 Rewards, and our technology is embedded into 7 Rewards. And every couple of months, they put new AR experiences delivered over the air using our platform into that. And there are experiences where you're playing games around Slurpee, cans, cups, Slurpee cups. There are games of like matching pairs, and the ones where you have to kind of follow an object as it's been hidden under cups and things like that. So just lots of kind of gameplay that takes place within a couple of minutes really suits our platform well. But you can build, really quite complex experiences in this if you wanted to. Any other questions? Someone over here?
Thanks. Do you plan to scale this to something similar to, for example, Unity? Because if we see a script there, like we can do everything similar to that. What are your plans in that way?
Absolutely. Like, I suppose our platform's a bit different to Unity. It solves a different problem. So there's definitely lots of things where there'll be features Unity has that we don't have or wish to have, and there'll be features that we have that don't make sense in Unity. I suppose the kind of core feature set is quite similar. So 3D rendering, physically based lighting, we have physics in the works, things like that, where there'll be tick boxes on both sides, I suppose. With ZapWorks Studio and the scripting functionality in there, the way we evaluate script, we have to do in a way that's App Store appropriate, if you like. Apple have some strict guidelines about how code can be executed on the fly. So we have to make clever engineering decisions about, well, let's say clever, like interesting engineering decisions about how we run code in order to apply with those regulations. And so that means, for example, in Studio, you're unlikely to get like a draw frame function where you're going to be able to do raw GL code, or you're not going to be able to write shaders straight away in Studio, just because we have to ship the shader with the app. I suppose WebAR changes that a bit in the future, because when it comes to the rules of what we ship in the browser, they're the kind of laws rather than a kind of third-party walled garden system. So I suppose the answer is kind of complicated. you'll be able to do lots of things in Studio. There'll be some things you can't do, but most of the time we find they're not practical restrictions. Cool. All right. Oh, sorry. Yeah.
Sorry about that. So the question is,
Okay.
could you elaborate on some of the applications on implementing this technology in the custom applications? Can this be done for, you mentioned this is web-based as well, so can this be done on hybrid mobile apps, or is this specifically for native devices?
Yeah, that's a really good question, and it's kind of a nuanced answer again. So we provide SDKs for iOS and Android, native SDKs that you import into your project in Xcode or Android Studio. We provide a Cordova plugin, which works with Cordova and Ionic and various other forms. And people have had success integrating those native SDKs into their apps built with a variety of frameworks. There is another option, I suppose, which is taking our WebAR technology and running it in a web view, if you like. So if you were to take something like Cordova, where your app is effectively a web page, then I suppose there's the possibility that you could run our WebAR technology in that view. Unfortunately, the views, the web views that are available to us on on iOS, so they are UI WebView, which is their kind of legacy one. There's WK WebView or WK WebKit, a name like that, which is their kind of more modern web view. And then there's a kind of Safari wrapped up, which is the SF Safari View Controller or something like that. So 3 ways effectively of embedding web content into apps. And in all 3 of those ways, Apple do not expose the camera APIs. So it's unfortunate, but we can't load content there. I mean, I hope that in the future they will change that. I think the answer, the reason for it, my understanding is it's not a policy reason from Apple. It's purely a technical reason, because those are separate code bases from Safari, and so Safari's getting all of the new features that WebKit acquires much more quickly than those other embedding technologies. So hopefully we'll get to see that, and then that will mean that new and easier deployment mechanisms for this technology within apps become possible. So the question there was, so the Cordova implementation is only available on Android. No, it's also available on iOS, but when we ship it for that, it has native libraries as part of that plugin. So the plugin has a tiny amount of like JavaScript and HTML, but when it's embedded, it becomes like a library that's linked into your actual application. So at the end of the day, it's not JavaScript and HTML that's running the bit that we show, it's our native code. So it ends up being a hybrid solution.
So it's 1 question per person, and then for in-depth dialogue, I'm sure you'll be at just outside of the room. So next question.
Hey.
Hi.
You mentioned image recognition. Was that on the client, or was that over the air, like cloud-based? And if it's over the air, could you elaborate a little bit on how that is managed?
Absolutely. So we have, it's cloud-based. So we have an infrastructure that can consume images and build them into collections, and then respond with arbitrary data for a given image. At the moment, that's technology that we have at Zappar. It's not integrated into ZapWorks yet, but it is coming to ZapWorks. But in the meantime, you can have the conversation with us, and we can discuss deploying that content together if it's of interest. But it will be the case in the future that if you want to use this technology, you'll be able to go into ZapWorks, you'll be able to take a given project and you say, I want to trigger this from this image, and then either your WebAR site or your SDK that you've integrated will be scanning, looking in that database and responding with images straight away and content. Cool. I have a few like summary slides. We've done all of the questions. Well, I put the summary slides up. That's cool. Here we go. Yeah. So I think as is clear, WebAR is here and it's pretty cool. There are some challenges that need careful consideration, but Zappar provides a uniquely comprehensive platform for WebAR. with a feature set that is really quite broad and very close to our native feature set. And we believe that WebAR is a very important step in the strive in our industry for ubiquity for this type of content. It really does unshackle you from the way native apps are deployed and made. And so for us, WebAR is really interesting and will be a keen focus at Zappar. Cool. So that's what I have to say, I suppose.